I wanted to go ahead and pick up where we left off with this slide because Bill and I talked a little bit that the best thing that I can do with you all today is to get into where you are finding examples of things that you would want to try in your own project, and then finding ways that the right fixtures and things that you would be able to use in Revit to make it work. Okay. So we know that we have these different types of fixtures. We have either surface, pendant, recessed. Track kind of goes in between these. It can be surface or recessed and even pendant. You can manipulate them a lot though, so they're very flexible, and then portable in landscape. All right. Any questions from what we started with last class? Yes. Yeah, we didn't actually talk a lot about that. I don't know where those slides went, but I did pull them out of my Art 105 class and a couple other older places. So that is where we're going to start today is CRI, because that's so important, and the implications if you're going from whatever is currently existing to something else, maybe not changing everything in the space, just some of it, what that means for what's going to stay existing or stay in the future. Okay, so I have a part 2 and a part 3. I'm going to kind of do about half of each one. So I'm going to just skip some of these, but we can also not skip it if it turns into that's relevant for some questions you have. So just stop me along the way anywhere. We can backtrack if we need to, but we are starting now looking at CRI, the color rendering index. So you basically, at color rendering index, you have what the light is going to provide you, right? That's the main tool we have for seeing color is light. Correlated color temperature is related to color rendering, basically to do with what light is painting the space. All right, so how cool or warm that white light is. And then foot candles is related to the brightness. Okay, what actually hits and bounces off surfaces. That's the main reading that we use. Okay, did you all talk about metamerism in human factors color theory? Okay, it's not as scary as it may sound, but basically it's the phenomenon of colors changing due to the different light. And there are lots of different categories of that. There's illuminant mesmerism, which is when the actual light is painting it to appear a different color or bouncing off to appear a different color to us. There's the observer metamerism, where we just simply see colors differently. We experience things differently. Geometric mesmerism, so whether it's the surface finish or the angle of something, that changes it. And then now we have device mesmerism. So that's where different screens and the real thing and a photo on another, type of, maybe just a printed photo, all appear different colors. Okay. So that's just an important kind of term. And you can see here, direct, indirect sunlight, and artificial light. And I think this slide, it's from my old company. I think these possibly are switched. Yeah. Because, well, why do you think those are probably switched? Yeah. So it is appearing brighter. There's at least a brighter spot on the wall, which then you have more contrast versus, right, and indirect light here. There are less shadows. There's a more smooth, even diffused light. Okay. So you don't have this point source as much. You have just this indirect illuminance coming through. And then you have artificial light. And of course, that's just one of many examples that could be there, how the same space looks so different given your light source. Okay. Here is what I think is really important to see and understand for color rendering index. Okay. So as we were talking about last class, the sun is our most perfect source of color rendering. All right. Now, the sun is not the same CCT all day long. Do you have an idea of what the CCT of the sun might kind of be like throughout the day from sunrise to sunset? Yeah, the Kelvin temperature of the sun throughout the day. The sunrise and sunsets are warmer. And then as you get to high noon, that is your perfect bright white, cool white light. Right? That's where you have the higher UV rays. Sunset and sunrise, you have more of the infrared rays. Okay. Incandescent, we went from sun to fire to incandescent light bulbs as our first artificial source of light to create interior spaces that were controllable light. And this was not horrible. It's almost kind of the opposite curve in a way, so that you got really good color rendering with incandescent lamps in the warmer colors and less so in the cool colors. Okay. Then you go to fluorescent. That was the next technology to come about. I think about twice as efficient, more or less, with energy consumption. So it was a big improvement, huge, still existing fluorescent all over the place. Maybe you can tell me what you see here for fluorescent FL. Have you ever bought something in a shop or even online, and then you get it in person in a different environment? So if you're in a store and then you walk outside or you open it up at home and it looks a different color. How so? Oh, like adjacency, like Albers kind of. Perhaps, yeah. But this is a little different because it's not just the adjacency of one particular color. It's really to do with the light sources. Yeah, yeah. So even if you had other adjacencies with the same light source, it would appear different from where you saw it. I think that these spikes give the same range of color rendering for our eyes. No, they don't. Okay, so for instance, my big example, it was a heart-wrenching moment, and I didn't know why it happened. Now I do. Was I saved up a bunch of money. Alex, you probably heard this in Art 105. Saved up a bunch of money because Birkenstocks were super in with socks. It was grunge time, and I never got to wear the fashionable stuff, but I saved my money and I was so excited I was going to go get Birkenstocks, and I knew I didn't want brown, but I wanted whatever. So I ended up choosing these gray ones. I was like, okay, so it's still neutral. I can wear it with anything. And they didn't have like all the colors that they do now. It's like, no, this will be good, just something a little different. And so I bought them. I wore them out of the shop, the department store, I think. And I was just so excited. And I get outside and it's this beautiful, bright spring sunny day, even though I do have socks on still with my Birkenstocks. And I look down and they're forest green. And I was like, this is not what I put on my feet, like, oh my gosh. Now I know, because that department store is still here in town, that they had, these fluorescent troffers up in the ceiling. So I was getting not all the green range. I was getting only a spike in that store. And so what I had was probably about here on the color spectrum. So for summer and folks, right about here on the color spectrum, it was reading as gray in the store. And yes, Ethan's right. There could be color adjacency factors as well, but I don't remember what the floor was, but I don't think it was remarkable. I think it was a very neutral color too. So I don't think that would have changed that too much. HID is high intensity discharge lamps. So this is what you would get in sporting arenas, like we were talking a little bit about sports lighting design. You'd get at the high intensity discharge, which would be a metal halide. And even before that, sodium discharge, which is super, you probably still see them occasionally for street lights at night, the super orangey lights. Okay. And then that leads us to LED, sodium discharge, high HID versus LED, where you have not everything, but you have a fairly good range, a curve at least, of color rendering that's similar to the sun and incandescent, but more balanced with the blue than incandescent was. When it comes from sodium discharge lamps for street lights at night for safety and switching to LED, that's a really fun dramatic shift. And they actually have been able to study it now enough to show that crime has decreased because from the color rendering, people can identify criminals at night better, what they're wearing, their skin color and all of that, their car color, color on license plates, all of this. And that has led to safer streets at night. Okay, so color rendering is very important. Now we need to figure out how color rendering is influenced by correlated color temperature. Okay, so correlated color temperature, we know inherently incandescent bulbs were like 2000 to 2700 Kelvin. All right, you can't really move that, negotiate that anymore. Fluorescent naturally is mid to cool white. Okay, So that depends a little bit. Fluorescent lights also have phosphor coating. So that's how they get the whatever color of white light. And again, the quality of the phosphors goes for uniform and consistency in a space. Getting the same lot of lamps is very important for that. And that's why larger companies with bigger facilities replace everything at once, even if it's not end of life, to make sure that they keep the colors consistent, especially if there's branding involved. HID, it varied greatly with the technology. Sodium discharge was always super orange. Metal halide was much more around 5,000 Kelvin. Okay, so two totally separate ones in the HID category. And now LED, we can do any of these correlated color temperatures, right? We can tune the white light as well as have almost a full spectrum of other colors. Here's a slide that shows this along with something else that I want to just point out today for us. So we have the brightness, the lumens. It's calculated this way for energy efficiency, lumens per watt. So how many watts of energy do you need to provide enough brightness? And you can see here for your average table lamp at 800 lumens, you would need a 60 watt incandescent bulb. The proper term is lamp, but we call the table fixture a lamp. LED is down to 12 watts on average. You'll find some lower than that now. Fluorescent is almost as good, but not nearly as good with color rendering, plus the mercury disposal, all of that. And then halogen is not much better than incandescent. All right, so this was a gap store. You can see here was what was existing when the team got there. It was, national team is what they were called. And they brought us in to kind of show a case study of better light while saving energy. And you can see here the compact fluorescent bulbs in the track lighting, which is very, very common, even now, retail shops. And then here, they're not aimed properly or anything on the right side. You can see the LED simple lamp change out, just the bulb. What can you see in the difference? The correlated color temperature. It's a little harder to see other things, especially since we do have really bright, glary spots here because they're not aimed yet. What do you see between the fluorescent light and the LED light? It has this tint, bluish, or I think grayish is what I see. And then while they're not aimed properly in the right side picture with the LEDs, you do have this brighter, crisper light. All right. So it doesn't help that we have slightly different camera angles. You know, it's hard when you're on the site to repeat stuff when that's not the main purpose. But you can definitely see just from those things that there's more clarity. And that's one thing when I was at Lightolier University. It's this whole well, it used to be like the gold standard for lighting design education. Now I think Cooper maybe has it in Atlanta. But that was one thing that they did. They had an entire room about half the size of this classroom set up, really, comfortable, standard living space with like an open kitchen and living room. And they're like, all right, go into here and sit down. You're like, okay, you do. And they're like, just notice how you feel, notice the lighting technology. And I'm like, okay, yeah, it's all CFL, blah, blah, blah. And we're just talking and relaxing, like, oh yeah, this is fine. This is better than the room we are in for 6 weeks this summer. you know, every day. It just, horrible seats. So then they're like, okay, now go into the next room. And it was pretty weird because it was the exact same room. And they're like, okay, go in here. And we're like, whoa. They're like, now notice everything. And we did start noticing with LED, there was it was almost like a very gauzy curtain had been lifted. So there's a lot more crisp clarity with LED lights, which goes towards color rendering index where we are picking up that much more information because of the better CRI, better color rendering index. All right, so these little things are very important. It's really exciting, but it also could be a deterrent in certain projects. So what could be a deterrent to having crisper light with more color rendering? A museum would actually be great because LED lights actually have the least damaging effects on archival stuff. No, think back to what would be a downside to having better color rendering index. All right. Well, this room I think would be probably a really fun tester, because while we see these, gray carpet tiles with some colorful stripes for some interest, and then we have our red chairs that graphic design graciously donated to us, which are way more comfortable than what we had. And even the walls, they're at least that there's some visual interest with the two different colors and everything. If we were to change it out to much crisper light with more CRI, higher CRI, then we would start seeing more of the stains. We'd see the things that don't quite match. We'd see more scuffs and stuff on the wall. Yeah, we would be able to see more of the colors. Yeah, the carpet, other than the stains, may look better. Yeah. Disregard the cockroaches, yes. Our little friends. All right, so you don't need to understand all of this, but basically, this goes back to color mixing, color theory, and how much uh, uh, how the physicists and scientists determine, test these different technologies to find out what they do render the best. All right. And oh, here's one more example, and this could be done so much better now. Okay, all right, yes. Yeah, yeah. So this is a textile shop in New York, and their sales were down. They're like, oh, what can we do? What can we do that's a quick spruce up? So they did. I would argue that this picture here, this is the updated lighting, that a different color temperature could have done even better, have a better result for them. But they wanted that warmer light as well as better color rendering, which I don't know if it really shows on these pictures or not very well, but you can tell that the product is more illuminated. So without even changing the type of fixtures, you get a little bit more. It's really hard to tell. It doesn't match my screen. The vertical and horizontal areas of product have better color rendering. Okay, I would say something more like a 3000 Kelvin versus that really warm 2700 would make a big difference still. But again, different shops have different ideas, different branding, and I think it does create a homier, more comfortable atmosphere. And the atmosphere, along with color rendering for product, is an important balance. Yeah, yeah, this is 2700 now. Yeah, I would argue that 3000 Kelvin would be as warm as I would go for something where color is so important. Because 2700 Kelvin, even in LEDs, is not going to give you the same color rendering. Okay, because these are coatings that go over these royal blue, almost like laser lights, LED diodes. So the more they have to manipulate that light to get it more and more warm, more yellowish light, the more you're going to miss out on some of that. It's still better than any other technology, but the warmer it is, you're not going to pick up as much of all the color spectrum. Here is the original sample of how CRI was used to test different lighting technologies. All right, so these colors were considered gold standard all the way from the time of Edison and Tesla for testing color rendering index. So what could be a problem with this being the panel of colors that you test? Yeah, they are. They're kind of dull, just shy of pastel, so some tint, some tone, like just even. And this screen is showing it way more. It's more of an olive green on my screen. Yeah. So it's a very kind of even amount of kind of gray added to all these colors, right? As well as tints. So they're like pastel, but toned down a little bit. I just checked on this as I was reordering some of these slides. This has been a couple decades in the making, and the last time that they republished this argument for this being the new sample was in 2022. That was the last time they updated it. So there is still amongst lighting nerds and physicists and everybody argument on getting this to be the new sample for determining color rendering index. So this is a much broader range. It's still not everything, but there is a point where you do have to find what you're testing. So this is a good sample board. I think part of that reasoning for not moving to this yet is that maybe there are some more adjustments to get a more fuller range of colors, right? But this is what at least would be progress if at least something like this would be approved over that one. Okay. So I do just want to briefly cover this because as you start thinking about what you want to do with lighting design, where are you going to draw inspiration from? Do you all have any spaces that you've recently seen or whether it's in a design magazine or in person somewhere that you're like, wow, that's inspiring. I love that. One of my classics is Le Corbusier for lighting design. I love what he's done in multiple things, especially his religious centers. The one on this slide on the right, I finally got to go see this summer. It was just across the border in France from Switzerland, so I was able to make like a 2 hour drive there with my grumpy family. And on a rainy day, anyways, I was like, we might as well do something else. So we got to go in there and experience that. And there was a light well over this smaller chapel area, and then these other amazing stained glass and not stained glass, really deeply recessed windows. That's one inspiration. Another one that I really love is the Light and Space Movement. That's a group of Southern California artists, kind of mid-century, more or less, that really explored materiality and how it plays with light and shadow, but mostly light and reflecting different qualities and even color. So very minimal materials typically, but really interesting, thoughtful experiments. All right. So before these things were very popular, they were finding ways of making things like this happen. So this happened. The original was early 1960s and by Doug Wheeler. And so this would have been a very, very difficult thing technically to figure out. Now it would be pretty simple, but you have this lovely diffused light featuring the edge of this one space. What you choose to do with lighting can visually change the volume of space for us. And does anyone know who this is? He has a lot of good essays. I'm sure you'll read some if you haven't yet by Donald Judd. This one is Larry Bell. That's one of my favorites. My sister and I, our dream is to just travel around for Larry Bell and James Turrell in particular. A few more of Larry Bell because he was such a genius with light and reflection and transparency, or is. I guess he's still alive, actually. And there are many more. I'm not going to go through all of them like I like to. This is one of my favorites. It's in the San Diego Contemporary Art Museum. So is this one. And then here's one of, do you all know who this work might be by? No ideas? Okay, this is James Turrell. So he is within the light and space movement, and beyond that, someone whose medium is light. All right, whether it's natural light or artificial light, color light. There are places all over the country and world where you can see his light effects, installations, different places. I'm just going to flip through a few of these. He has one work that's almost done. Crater, what is it? Crater Valley? Crater something out in the desert that's almost done. It's been 50 years in the making. And it goes back to designing with the sun and planetary alignment and all these other things that could happen with that. This was one of his earlier breakthroughs with light as strong projection back in the day. This was on a more recent cover of Interior Design, which I found really interesting because it's such an old installation, but where he makes the appearance of a 3D cube in the corner of a room through light projection. So he's at the forefront of that kind of stuff. Someone who I got to get to not personally know, but know his work a little bit this summer is Olafur Eliasson. He's an Icelandic artist, and I feel like he's pushed into kinetic movement and all these other things. All right. Here's some boutique hotels that kind of get inspiration from the space and light movement here and there. Here's where they flipped everything on its head. So the floor is illuminated instead of the ceiling, and the ceiling looks like a carpet and very Alice in Wonderland-ish. And then I also want to give you some more already implemented lighting design ideas. So the IALD is the International Association of Lighting Design and Lighting Designers. I think it's designers, actually. And this is a very exclusive group of people from all over the world who have earned their their LC, sorry, allergies, which is the lighting certified accreditation, which is really hard to get. You have to know your physics, your math, everything else, lighting layouts, everything. So their website, you can find a lot of lighting design award winners and honorable mentions. Okay. So I thought that we could do a little research on our own and find some things to share, and I can walk you through how it was implemented. So this one, you have some recessed adjustable track lighting. You also definitely need to pay attention to all the finished surfaces, right? So that helps a lot. You have the curtain walls, and then you have some lovely lighting around the edges here to illuminate those walls pretty uniformly and get that vertical repetition going. And that's what a lot of lighting design is. It's not the pretty chandelier that you put in at the end. It's the effect that you get from something that you can't even see the source. That this is a lovely theater that also earned an award, and you have a few different layers of light. You have lighting around the perimeter on the top and bottom. You have the sconces creating this rhythm along this other vertical repetition. You have some downlights, so you're lighting up the floor where the entrance is. You need to light the space for the people. You have daylight coming down from above diffused, and then you have the interesting decorative lights that also add a little bit more to the space, right? So it kind of draws you. So here's where I need to come in. I'm here, and then around the space, and then up. Not a lot of these pop quizzes are things that we necessarily need to go through, but maybe just a little bit. So where are surface mounted luminaires most often used? Precisely. That's exactly where they're most used. What makes that a important type of fixture to have? Okay, not enough space above. There's no plenum. We have solid slab ceilings, and then not particularly high ceilings, although this is definitely, I think, better than what's in the other spaces. That is a solution, is the surface mounted, right? That's almost the only time they're used is when there's not enough plenum space. Okay, exit signs, that's just nice to know that they would normally be on the reflected ceiling plan and that you would be a part of kind of that. The other thing that you would need to also be looking at is the mechanical plan overlaid with the electrical or the lighting plan or reflected ceiling plan, depending on how big the job is, to make sure that the mechanical fixtures are not in the same spots that you want lighting fixtures. Okay, if it's flexible ductwork, then they may be able to negotiate the mechanical into a different spot, but oftentimes it's the lighting fixtures that need to change or move. And so that's one reason why lighting sometimes comes in towards the end, or the lighting designer might come in towards the end instead of the beginning, which, you know, ideally everyone wants to be there at the start of the job, but they might come in at the end because suddenly that lighting technology is no longer going to work because the layout has to change so much. So what other fixtures, what types of fixtures could be used instead, right? And there's not one single right solution in any space. And that's the nice, beautiful thing about lighting design, is that you can find a solution to any problem within reason. Okay, we didn't go through math. Important criteria for designing a lighting cove that would include which of the following? Oh, and by the way, this is an NCIDQ kind of question. So probably aren't going to worry about ergonomics, right? And you do not need to support framing with lighting. Lighting is supported by the framing sometimes. Okay. Medical clinic. You almost always want to make sure that you are viewing all your finishes and samples under the actual kind of lighting technology that'll be there. So whether it's some sort of point source, you know, we have these teeny tiny pinhole lights, which I personally love, that could create sparkle or all these other things, or you have the more diffused 2x4 troffers or whatever else you're using these. It's really important to have the right technology and the right fixture even to view your samples for an entire project under so that you can see, oh, you know what, I really have to look at the reflective interaction of light off this, I don't know, stainless steel counter surface or something, or super shiny tile or whatever it is, and as well as the CRI, the color rendering, make sure that it's all accurate. Color rendering index. Yes, it goes to 0 to 100. There are some newer technologies that argue, but it's hard to know with the color palettes that are being tested with, that they are over 100, which 100 is what the sun is. Theoretically, we can't achieve sunlight and nothing is up to 100, but most LEDs, if they're of any good quality at all, are above 90. They're 90 plus. Okay. A lot of them will be like 93 or 96. So they're all very good. All right. And of course, the correlated color temperature, the color of the white light will adjust slightly depending on the CRI. No, sorry. The CRI will adjust according to the CCT slightly. This is one of those NCIDQ questions that bug me because it's like, well, there's so much more information I need to actually tell you. But as the lighting questions on NCIDQ are really annoying. D is the answer. Yes. Yeah. Yeah. You definitely want to actually consider it under the actual samples. Okay. And again, this is a medical clinic. It's not a surgeon's suite. So it is more about the experience overall of, yeah, someone coming in. Getting the texture from a rough plastered wall would be, of course, we don't need to do incandescent anymore. This is the kind of thing that's on the NCIDQ still. But they did just, update it. So who knows, maybe they've phased some of these out now. Benefits to LED lighting, including high CRI, energy efficiency, long life cycle, reduced operating costs. What are not downsides to LED? Well, no, a quickly evolving market is not a good thing for tech. I mean, it's a good thing for technology, but not for someone who purchases something that's an investment and they're going to want to have it there for a long time. So as soon as you install it, something better is coming out, right? The quality and sourcing of the phosphors is so important to good quality. See, we have the double negative. It is expensive, but it's not saying the expense of it, the quality. Lumens over life cycle, high CRI, that's a good thing, right? High color rendering index, lower energy consumption, that's a great thing. This is what the answer. Yeah. Lumens over life cycle. So with LEDs, they do slowly decline. So instead of just suddenly the lamp fails like in incandescent or fluorescent lamps, they just slowly get dimmer and dimmer and dimmer. So the original LEDs that last time I checked at least, that were tested for life cycle, how long would they last? They're still going. They're just so dim that they're not useful anymore. Yes, exactly. Where they cut it off for the life of an LED is when it reaches 70% of the original light output. Lumens over life cycle has to do with that versus the life cycle ends abruptly. Okay, it's 70%. So 30% decrease of the original light output. All right, this is a pretty important question because if you get into especially office design and you have a lot of computer workers of any kind, you need to know how to light it properly. Okay, so what type of lighting would be most appropriate for a call center where each employee works in front of a bank of computer monitors? We definitely don't need the surface lighting as much. We're not all working on paper or off paper, reading a lot of stuff, drawing a lot of stuff. So we don't need as much direct light on our surfaces. And yeah, we don't have as much issue with glare on almost any screens now. I still have some glare issues on this, but so indirect or something kind of like this where you have but kind of the reverse where I think this is like a 20-80 distribution. So you have about 20% of the light going up and 80% coming down. I would say the reverse where you have semi-indirect. So it's mostly going up, but a little coming down on your desk. Yeah, and because this is not a very tall ceiling, these could suspend quite a bit further in a bigger space. Then that would be, if we had a little more to drop it down, then it would give a very uniform illuminance. Yes, right. Yes, and all the other stuff on our ceilings here, solid slab concrete ceilings. Um, but still, I think this is the best solution that we have in here for general lighting. Right, you need your task lighting and general. Yeah. Yeah. So choice is always the most important thing you can give in any kind of design, whether it's seating or temperature control, lighting control is choice. So that's another reason why you want layers and different types of lighting fixtures. Okay, so into this one, I don't know how much we really want to do in here. I'd rather give you all time to explore and try to give you some ideas for how you would implement those specific types of lighting design. So do you all want to go onto the IALD website, International Association of Lighting Designers, and look at some of the awarded projects? And this is just the three categories of retail. It was a presentation I borrowed from our national team because they work with all the retail and chain stores, and it just looks at a bunch of different types of retail. So you have the big box stores, department stores, and honestly, going to the mall is a great way to look at lots of different lighting options, um, and seeing how you feel, and even see which stores you just want to go into and why, even if it's not really your style or something that you would want to purchase. What makes you feel drawn into that store? Is it the brightness? Is it the comfortable, CCT? It's a good place to do that, and also see what not to do, right? Boutique stores. I love to live in the boutique design world, not just stores, but hospitality, and see it gets more and more interesting in these more bespoke spaces. And of course, the branding, especially in retail lighting. You want to light the humans. Same in a conference room, same for, well, think about COVID and everyone who needs lighting just to be on virtual meetings, and then some different types of lighting and where it's generally used or sometimes used or not used at all in these different types or categories of retail. General light levels from IES, the Illuminating Engineers Society, which is very important. You definitely want to know the recommended foot candle levels, the brightness that you should be designing for. AGI 32 is the lighting design software that does that. And I'm sure Revit does some of this where you take into consideration the quality of the finishes, smooth, glossy, reflective, matte, textured, as well as the colors and how all of that, the darker the color, the more the foot candles are not going to bounce off the wall to give more luminance. So the darker your color scheme, for instance, the less foot candles are actually going to be produced or bounced onto the things that you want to do. So if you have a really dark, moody space, you're going to have to bump up those foot candles more. Whereas if everything's light, then it's going to be pretty easy and more predictable what the foot candle performance will be in the actual space. All the different foot candle readings, the predicted amount is really important. You can see if your lighting layouts are uniform enough for your general lighting. Can you turn off the different layers of lighting? Okay, so you can see then, okay, my general lighting levels are going, my ambient lighting, that's going to end up being 20 foot candles or 30, and is that enough? And then you go on and you see what other things add to add the spots that you do want to be brighter with different levels of light, different types of lighting fixtures. Oh, so Ryan, here's a graph for what you were asking about. Sorry, not Ryan, Alex, what you were asking about basically comes down to the lifetime of LEDs. This is one thing that certain decision makers will want to know about with anything that has to do with energy reduction in your design is what will the benefits be? So there are hard benefits and soft benefits to almost everything you do in design, especially when it comes to energy, anything to do with energy design, electrical design. You do have the advantage of hard benefits. So money saving benefits, which helps either fund the project or help you sell your idea the way it is versus cost engineering things out. All right, so typically prior to LED technology, this is kind of if every lamp cost $1 on the far right, the distribution of the the pennies into electricity, labor, and lamps. So the actual, yes, yeah, okay, but in percentages, yeah. Um, and then the graph, it shows incandescent over the very short life, which is under 10,000 hours. And then different technologies going up from CFL, different halides, fluorescent, and then lighting class LED versus the little bitty early on LEDs. Okay, so knowing how to show those savings is really important. And it usually comes back to payback in the number of years that it would take to pay off the project. So the cost of doing this type of energy saving upgrade to a building. And that'll really help the decision makers say yes, especially if it's under a year. That's a no-brainer for them. If it's under, I think we discovered under 4 years was still usually going to work. Then over that, it depends on what it is. And then you can also see kind of the environmental benefits to any kind of energy saving design. But lighting really is a low hanging fruit for that versus mechanical equipment, HVAC equipment, things like that. All right, did you all find anything yet? Oh, right here. Yeah, my Apple shortcuts. And they don't work. So were you looking at images? Okay. All right, which one stood out to you? So that is probably the same room, but different angles as this. Oh, come on. Where are the pictures? Oh, okay. Ooh, yeah. This will be fun. Um, so it does look like from really great, powerful lights. Yeah, it's hard to say. Yes, yeah, like the cylinder or oval cylinder or something. Yeah. I don't think that they're producing light. And I thought at first that the parabolic arch produced its own light, kind of like a paper lantern or something, but I don't think it does. But surely it's not just those spots way up there. But if so, especially this angle, right? Yeah, it's very even until you get like down to the floor where I don't know if that's like it's some sort of corridor or entrance. That's what I had initially thought, but I don't but now that I'm looking at it, right. Oh, this one? Oh, you know what? Yes, I think that inside these little tubes here, in addition to reflecting on the outside of the metal, maybe there is something in there, but this side isn't really showing that. But there are moments where you're like, oh, there's some lighting peeking out. Well, yes, there are two, yeah, cylinders of glass. Yeah. So there is something back there. I wonder if it's like diffused daylight or is there some kind of material behind the so there's lots of shiny surfaces here, first of all, right? Glass and metal. And we know that there are the light sources up top. But I want to know, it does, okay, it does look like behind these there's some sort of illuminance diffused, right? I know, let's go. Yes, this is Arizona. Oh no, wait, this is in China, Kunming, China. Why is this on the Arizona Awards? I don't understand. This is so confusing, but I love it. I love it. And I think this is a really neat one to look at. Any other questions about in this particular design? But this is the kind of stuff, if you ever have questions, whether it's how an artist did something like Olafur or James Turrell, there we go. How they did whatever kind of effect in their light installations, or projects like this that you find or lighting design awards, you can just email me or text me with them, okay? I'm happy to, I'm a nerd. I like to sort it out. All right, thank you all. Bye, Summer.
This might be better off just as a watch and do in terms of getting the time through here. But I want to show you a couple of ways of dealing with Revit's pretty good but still somewhat limited way of dealing with lighting fixtures. It's not really what it's designed to do to a professional level of lighting design. As Mollie mentioned, there's a program called AGI 32, which has its own whole huge learning curve and expectation. You probably would have an engineering degree before you really start using that. It's pretty extraordinary. So what I want to deal with today is really three things. I'd like to start with a couple of fixtures that you've probably known or experimented with as you're doing assignment number 2, and then move on to a couple that I think you probably haven't seen. So let me put a ceiling on this, put some walls around it, and then a ceiling. Go here. I'm going to get rid of this. I'm just going to make it an entirely interior space so we can see lighting starting to happen on it. And I'll set up an interior view, sort of looking this way. We'll pick up the door a little bit. So if I'm just going to render, for all of these, we're going to just be doing interior artificial only. We're not worried about the outside at all at this point. And if I render this, as you might expect, we're just going to get blackness. Doesn't matter what, I'm just making sure I've got all my holes plugged. Okay, so if we put just a regular old downlight here, I think we got some of those here. Downlight recessed cans, we'll use this guy. I'll put one out here over the table and one over here near the wall. And render. Not too impressive. When you're lighting a space, the question is, to get it adequately lit, is how many fixtures do I need and how bright do they need to be? I noticed in the ones that Mollie had, it looked like, I think it was the first picture she showed of a high school cafeteria. It looked like they were those 2x2 bright fluorescent fixtures, maybe every 8 feet or something, which seemed to be balancing the daylight and all. I don't know what their actual light output was. To us, to some extent, this is going to be a matter of trial and error to see what we want to get. I would like to have the sense that this fixture right next to the wall is really a lot brighter than that. So if we pick here in all these, in edit type is where we go down. I know this is a bit of repetition. And here's the problem with using watts, is if you say 100 watts at a certain number of lumens per watt, you get a certain brightness. If you say 100 watts at a different number of lumens per watt, you get a different brightness. I'm really moving all to lumens, just because it gives me a number I don't have to multiply by something else. It's just like, how bright is that? I don't care how much power is coming in. I just want to know how bright it is. And let's just say that that's 1750 lumens to be the same brightness. And I want the brighter, so let's say 2500 lumens. So all we've done is replace the lamp in this fixture. Now render it again. Okay, so that's about the same brightness. As a rule of thumb, double the brightness to get a noticeable effect. Edit type. But this is really getting pretty bright. A 250 watt bulb is a pretty big one. So instead of this, I'm just going to add more light fixtures to this room. Go back to the ceiling plan. These are all the same thing. Go back. And I think I will just go to edit type and crank that up another. I'll maybe double it just to see where we get. Make that 5,000 lumens. And I think as you're working on your projects, this is sort of the process you'll be going through. Okay, so there's a room lit by these guys. And you can sort of get a sense of the shape of that cone of light coming out of this guy by how they hit the walls. With all those spotlights, all these recessed cans in edit type, we have 3 controls determining where it's aiming in terms of this way, called its tilt, and how wide a beam spread it has, and how tight the spot is. And so in this one, we'll keep it aiming straight down. That's the 90. The spot field angle is the whole width of the illuminated area, fading out at the edges to no illumination, while the spot beam angle is the narrow area that gets 100% of the illumination of the fixture. So this is fairly wide. If I make this tighter, the center part, let's leave that at 30, but take the field angle, the wide one, down to 60. What we'll see is lower scallops on the wall. And you can decide that's an effect you want, or that's an effect you don't want. Yeah, they're a little lower down because we've tightened that. And if I make them the same, the full brightness will come right out to the edge, edit type. If we make these 2 angles the same, I'll make them 60 and 60, so it stays up there on the wall. Render again. We should be getting a very hard, okay, so it's moved up, and we're getting a very hard edge right there. So as you play with those, experiment, let's say, do your research to see what you want and how you want those to work. I've cut out a couple of minutes where I couldn't get a wall washer to behave. You'll see it popping up shortly. Let's see what else we can do with light fixtures. Let's look again what's available in edit type. This is for our whole slew of them. We've got the tilt angle, which right now is 90 degrees straight down. We've got these 2 field angles, which are at this point set the same. We've got a brightness. We've got an initial color temperature. And as you know, we can change that, let's say to our D50, which will make them all cooler. And we can also add color filters to them, as in the theater. So if we wanted to do our Halloween room, we could add a red filter to those. Just say red filter. Okay. And then render that. And this is a case where you might want some of them to be red and some of them not. So you'd like do a duplicate type and have a red downlight that would have the red color, the regular one to be white. So, and what's hard here is we have what looks like a white instrument giving us a red beam. And that's because what's in here, in this one, is a disk of glowing white material that Revit provides as sort of a cheat to make lights look like they're on, even if no actual light is hitting the inside of the housing. Easy to make and easy to edit family, but it's really not behaving the way families actually do. It's like close enough for Revit work. If you really wanted these to show as red in the ceiling, you could duplicate the white glowing material, change the copy to a red glowing material, and use that in the family. But what I do want to show you is ways that we can use that same idea. I'm going to Control Z back or get back to where these guys are just white. A bunch of the slides we saw, there were like strips of lit illuminated material, sometimes on the wall, sometimes on the floor, sometimes on the ceiling. There's a Revit material called glass white high luminance. And we can just model things with that material, any shape we might want, and anywhere we might want them. Just like these look like they're on regardless of the light conditions. The problem is that a feature of them is that they don't actually illuminate anything else. They just glow on their own. So it's not like neon, a tube that you'll see the tube and then you'll see where it's lighting the wall behind it. So let's take a look at how that would be. I'm just going to make a shape here on the wall. I'm going to go to architecture, component, model in place, and we'll call this a light fixture for lack of better. It's not really a lighting fixture. And we'll call this wall design fixture. It's going to be an extrusion. I'm just going to make it like an inch thick or half an inch thick or something rather. I'm going to set my work plane. Is that a wall? Yeah, that's my wall. That's the wall. And I'm just going to make a shape here. Here's that, and then we'll make the whole thing, let's say half an inch thick. Okay. And then this thing, I have to go back to edit in place to give this that glowing glass material. My category, got to change that. Do glass. And it's this one called Glass White High Luminance that comes with all the Revit templates. And we'll just say, okay. So now if we go back here to render this scene, what we get is a glowing thing on the wall. It's not going to light anything up, but you see it's not affected by shadows or any other lighting things on it. And if you want a little bit of modulation in there, we can go back to edit in place. Go back to the material. And this material, we have some choices about how, as it's self-illuminated, whether we want this to just be a dim glow or like as bright as a cell phone screen, a couple of things through here. Let's just take it to dim glow and see what the difference is. The number itself is like candelas per square meter or something. I have no idea what those are, so we're not going to deal with that. Let's just say dim glow. Okay. Okay. Sorry. Render. So that's really dim. I mean, obviously we got to be somewhere somewhere in the middle. Let's say I think it started out being lampshade interior. I'm just going to knock it down a little bit to LED screen where we get a little bit of tonality in it. So you pick that up until it works with whatever your scene is going to be. And the next thing I want to look at is cove lighting. Let me just put a cove lighting in this along this wall. For instance, we'll just do this. Let's get my first floor plan. I'll just make it along this wall since that's the one we're looking at. I'm going to draw a section through here. View section through here. So here's my wall. Here's my which is my, I guess this is the wall with the door in it. So what I'm going to do is just put in, there's the ceiling and the wall, is put in a cove that comes down from the ceiling and over and leaves some space in here for the light. And I'm just going to use that architecture component model in place. And we'll call this being part of the ceiling just for lack of better. And we'll call this Cove 1. And I'm going to create an extrusion. And I need to pick a plane to draw that on, which will be this wall back here, if I can select it somehow. There we are, on that wall right there. And I'll come out like a foot and come down a foot and over a little bit. This is just to hide the actual fixture itself from people's view. And let's say make this 10 feet long, and we'll adjust it later. So there's our little ceiling cove piece. Okay. Okay, and I'll go back into my ceiling plan. And there's that, what we just drew, and I'll drag it all the way down to there. And then I want to put a light fixture in there. Something I made and uploaded is there on Blackboard. Where's my Blackboard? Here we go. And what this will be is a we're down in week 11 here. Is a bare linear lighting fixture. It's just a glowing tube. It's like one of these without any of the housing. It's just the lamp. Open file. Okay, it's there in downloads. Get out of here. Back to Revit. So I'm going to go to architecture or just do CM for component. Load family. We're in downloads. Bare linear lighting fixture. And I made it 8 feet long to start with, but we can change that. Okay. And I'm just going to put it there. And the question is, where is that? So I'm going to bring back my to here. And right now, both the beams and the actual bulbs are turned off in this view. I want to see them. For this view, I'm going into visibility graphics, sliding down to lighting fixtures, and turning on the light source, turning visibility on for light sources. And so we can see there's that one. This was the wall washer. Here's a regular downlight, and we can see its source as sort of this yellow thing in there, and we can see its beam as well, but it's hard to see them. So something else I want to do is change in all these views. I would like those to appear like a richer orange or something that I can actually see. And that's in manage object styles. Again, we slide down to lighting fixtures, say light source, and instead of that pale yellow, I'm going to make this like an orange that we can actually see. So now we can get a sense of how those are actually being shown, and we can now see this 8-foot long light fixture that I inserted, which has got no housing around it. It's a bare bulb, if you like. So I'm just going to move this up to here. And what I'm expecting now is when we turn it on, it will shine here, bounce a little bit, and illuminate this part of the wall. And I think what I'll do, if I have it over, let me make this a little bigger. If I have it over in here, right there, we're going to get a shadow. It'll be lit up here, and then we'll get a shadow line right across there. So I'm going to move this guy so it's like just right on top of the edge of that. So the light will shine straight down the wall and maybe hit the floor a little bit. Who can tell? Get rid of this thing. That's confusing to me. But we got a sense of what that's like. And it's worth noting that these guys, well, we'll come back to them. Go back to my 3D view. So back there, behind there so here's my glorious glowing thing, which I think I'll kick up a little bit just to make it look like it's really glowing. Edit in place. Oh, it's actually that material I want to edit, isn't it? LED screen. Let's do lamp. Let's go back to lampshade interior. That's what it was before. Lampshade exterior. Okay, apply. Okay. Okay. So now I want to go back into my ceiling plan and be able to extend the tubular fixture I put in the whole length of that wall. So ceiling plan, and we'll see that this is from here to here is 33. We'll call it 33 feet long when we get in there. So I can go, say ceiling plan. Let's go to here. If I pick this now, the elevations of these are very strange. I don't know what they're connected to. I think it comes in like 5 feet off the ground, and then we're moving it up from there. I haven't been able to make sense of that. But if we go to edit type, we can come down here and say emit light from a line that in this case will be 30 feet long, the whole length of that wall. 30 feet. Okay. And if I get into, I need to be able to see that in a plan view. So you would think that ceiling plan would do it, right? Ceiling plan, not in there. Light fixtures. Oh, I have to turn it on. I set a global color for it, but I have to turn it on for each view that it wants to be seen in. Okay. Why? Okay. So there are these guys. So you can see how that could get kind of confusing. And there's that. Let's go back to 3D view 1 and try rendering this. See what we get. Don't know what the its brightness is. Oh, okay. And this is important, crucially important. Here I'm on my typical medium render quality, which Revit understands as a way to save time when you're rendering. So it just uses a point light source. You always have to go with these linear light fixtures up to at least high to get the whole light. Otherwise, it's just the one endpoint gets rendered. And that's noted in here. So there's that. Now you see we got a couple of weird things going on. One is that these lights are so close to this that they hit and they give us a shadow. So I think I'll move them out. And also our light there, it's there, but it's not very bright. So I want to move these out and crank that up and then see where we start seeing where we're getting. Stop. Yes. Ceiling plan. So there's a bunch of backing and forthing going on. So these guys, let's just get rid of them. And then this guy, edit type, we have some nominal, I'll take it from 3000 up to like our reference white for color temperature. And then I don't know how the lumens apply to something that's that long, but it clearly wasn't bright enough. So let me just make this to be 10,000. Apply. Okay. 3D view, render, high. Go. Oh, here's something else. When you're rendering on the desktop, it's sort of nice to see these things big, but if you make them small, they'll render a lot faster. If you make it half the size, that's a quarter of the area. So a quarter as many pixels, so it'll happen in a quarter of the time. So let me just try it like this and see how this goes. Just to get a sense of what that looks like. Okay, that's looking better as far as I'm concerned. So at that point, I could just zoom in and say render this again. And come in for the higher resolution. Given the kind of facility I'm trying to create here, I could have done this with a warmer color temperature to give a nicer look to that, a warmer look to that wall, but that's where it's going to stay for the time being. Okay, almost done. No, I don't know. I'm waiting for this. last kind of fixture I want to introduce that might be of some use to you at some point. Let's go back to my first floor plan, or go back to my first floor ceiling plan, let's say. Are things called studio lights. And a studio light is basically just a invisible beach ball in the air. So if you just want to give some light to a room, but you haven't really decided on the sources for it yet, you can just put a couple of these in and it'll light the room up. And I'm trying to think how best to, I'll just get rid of all these just to illustrate. We'll leave that on and we'll do CM for component load model, imperial, lighting, architectural, internal, and they just call this studio light. And it's just a glowing orb. And I'm just going to put a couple of those in here just to light up the room. And they're probably like, you know, right now they're also up near the ceiling. So let's select all instances in entire project and move them down. Go back to my 3D view where I can see them because they're, you know, it's turned on, but when I render, I won't be able to see them. Didn't we have a ceiling in here? Did I erase the ceiling? I bet I did when I erased all those light fixtures. Ceiling plan. Put it back in. This is what happens when you try to go as fast as you possibly can. Okay, let's see a ceiling. Okay, ceiling is back. So these guys will sort of make lighter places on the ceiling and on the floor. But they give light to a space that otherwise wouldn't have anything at all. And maybe those just go in while you're figuring out what you want, and then you go back and get rid of them later on. You know, if they were down near the furniture, they would make the furniture be very bright. So we have a couple of things. We have, just to sort of go where we have this, which you can see it and it glows, but it doesn't illuminate anything. We've got the studio lights, which you can't see, but which do illuminate things. And then we've got the linear light fixtures, which we would not see and do illuminate things. So a couple of non-standard effects. We can make a family of a strip that could then just be placed on a wall or a ceiling or a floor even. Interesting to see what would happen if we move this, copied this down to the floor level. Let's just look at that. In fact, how cool would this be? We could have that linear fixture there on the floor to provide the illumination and a glowing strip on the floor to look like an embedded light source. Many possibilities here. See you Tuesday. That's been fun. Thank you. Thank you for being here, putting up with me.